Okay, so 2.4, remember that one I showed that was in brackets and we FOILed out, and then we did the derivative on. Today this lesson, we're going to learn how to actually use what's called the product rule. Now, the product rule, if both f and g are differentiable, okay, so the derivative, you want to write it in both ways, of f of x times g of x is the same thing as g of x times the derivative of f of x plus f of x times the derivative of g of x. Okay, now that's written out in that way. I'm going to show you just if we just have f times g, find the derivative of it. It is f, derivative of f, times g plus f times the derivative of g. Or f g prime, or f times the derivative of g plus g times the derivative of f. It's actually pretty hard to mess these up unless you do the same thing twice. It looks like this is going to be so hard to keep track of. The point is, in every pair, take the derivative of one plus derivative of the other in the other pair. Okay? So you never take the derivative of both in one pair, and you never want to take derivative of one times the other plus the same derivative times the same function. Okay? You don't want to do the same thing twice. So you can do derivative first times the second, and then leave the first, derivative of the second. So derivative of the first, leave the second, plus leave the first, derivative of the second. Or what I do, this is the way you'll see it most, is I go first times derivative of the, we'll just go like this, derivative of the second plus second times derivative of the first. Now, there's a long proof to show you this, but I'm going to spare that today because of doing two lessons in one. Now, remember we did this one just like this. We could FOIL it out and then use the power law. Okay? That's always an option. And maybe if it was a test and I had extra time, I would come back. So this isn't the nicest, easiest one to start off with. Oh, there's an easier one. No, they're all mean. Okay. So this one here. So we're going to do f. So for this one, we'll do f prime g plus f g prime. So you just got to keep things straight. Now, so there, y prime equals. What's the derivative of, we'll call this f, and this one g. What's the derivative of 2x cubed plus 5? 6x squared. So it's derivative of the first times second, and you leave it alone. Plus f, left alone. And I don't do it this way because I always like doing derivative and then the other one. Derivative, the other one. Okay? But all the rest I'll do that way, but it depends which way you like. It doesn't matter to me. What's derivative of the second? 6x minus 1. It's quite unusual on the, that's where I was on Friday, is I was, they had the chief marker, the AP marker down from the States, and he was just going through the AP exam. And when they ask you to do anything, like do the derivative of this, don't simplify it. You leave it here. They'll give you full marks. If you do the next step and you make a mistake, you get marks off. If you do the next step, so don't simplify it if it never says simplify. Okay? Since you're not marking or writing the AP exam, you don't care about that knowledge at all. Okay? But if the question is just like saying it's a written response and it just says, can you do this derivative? They want to see, do you know how to do it, right? It doesn't always mean just simplifying it. But for us, it does. Okay, we're going to keep going. So y prime equals, we're going to multiply this in, 18x to the 4 minus 16x cubed plus, and we get to FOIL this. We're so lucky. 12x to the 4. Oh, 6, sorry. Yeah, I would have, see, quit while you're ahead. That was the moral of that story. 2x cubed plus 30x minus 5. There's so many rules that I learned on Friday. I was like I would have never known. Like if say there's the question and you rewrote the question, but you wrote the wrong question, as long as you didn't change the complexity, you still get all the marks. But if you made the question easier by doing it, then you don't get any of the marks. So what are they trying to? They're not penalizing you for, right? Because we all make those little mistakes. Actually, you'd lose 1 mark, but it'd be 1 out of 10, right? Which isn't that bad. So no, it's not. So y prime equals, we got 30x to the 4 minus 8x cubed plus 30x minus 5. So the other way, FOIL it out at the beginning, and then you can take the derivative, you'd get the same answer. Yeah, I probably would FOIL that one out first. But okay, so the next one. Yeah. Now, this one we're going to be nice and we're not going to simplify. So probably the best way to always do this, I think, is to get them to fractions. All your exponents to fractions. So I would rewrite this as 1 minus t to the negative 1. No, I'm not doing the derivative yet. I'm just actually rewriting it. Plus 2t to the negative 3. So this is still the function. Okay, I'm not doing a derivative yet. And then t plus 1/2 t to the negative 4 minus 4t to the negative 5. Okay, so for this, we won't simplify. So this is the type of question that I would give just to see, do you know how to do the product rule? So the first thing, so we're going to go the derivative of the first times the second. So f prime of t. So what's the derivative of the so we got negative 2t, or no, sorry, what are you talking about? we'd get t to the negative 2, because the negative 1 times negative 1 is 1, minus, no, because there's a negative there already. Okay, and then negative 6t to the negative 4 times t plus 1/2 t to the negative 4 minus 4t to the negative 5. So derivative first times the second plus, we can go with the derivative of the second now, which would equal okay, this is first, this is second, right? Let's do derivative second would be, what's the derivative of t? 1 minus 2t to the negative 5 plus 20t to the negative 6. Yeah, we all heard him say negative 4. But it really wasn't. Times just your original. 1 minus 1 over t. Oops. Well, I guess I should keep it the way it was. 1 minus t to the negative 1 plus 2t to the negative 3. Okay, so probably the only next step I would do on this one, it's not really simplifying, but you should put them in the form that the question was given. Okay, so f prime of t would be 1 over t squared minus 6 over t to the 4 times t plus 1/2. All I'm putting is the getting rid of negative exponents, right? 4 minus 4 over t to the 5 plus 1 minus 2 over t to the 5, 20 over t to the 6, 1 minus, oops, 1 over t plus 2 over t to the 3. Okay, we should do C just because it's just ugly. Okay, so G prime of x. So if, oh, actually, sorry, let's get rid of, let's do g to the x, let's get it all to exponents, be 4x to the 1/2 minus 6x to the 3 over 2. And that's x to the 5 over 2 plus 2x to the negative 1/2. So g prime of x equals. Now we can go first times the derivative second, plus second times the derivative first. Let's try that one. So first times derivative of second would be 4x to the 1/2 minus 6x to the 3 over 2. That's first times the derivative of the second would be what? 5 over 2 x to the... So how are you doing this in your head? What would you do? So 5 over 2 minus 2 over 2 be 3 over 2. Very good. Okay, what's going next? 2 times negative a half. No, well, let's do that. Let's bring the negative half down first. Would be negative 1 to the, we're going to minus 2 over 2. So that should be negative 3 over 2. Plus, okay, so let's do, that was first times the derivative of the second. So we'll go second, which is x to the 5 over 2 plus 2x to the negative a half plus times the derivative of the first. And if you want, you can always write first and second up here to keep things straight, okay? So now we're doing second times the derivative of the first would be two x to the negative a half minus 9 times x to the 1/2. Okay, so the only thing that's left, we don't have to simplify it, but we need to get it in the form it started with. So g prime of x equals, so that's 4 root x. So you can see we're using a lot of that pre-calculus unit here. Minus 6 root x cubed times 5 over 2 root x cubed minus 1 over root x cubed plus, don't forget that plus sign, x to the 5, so root x to the 5 plus 2 over root x, 2 over root x minus 9 root x. That would not be fun to simplify. Okay. Now, number 2, in comparison, is quite an easy question because you can do it all in one line and there wouldn't be any simplifying after. Okay, so if we call this the first, this the second, right? So if we do first times derivative of the second, so oh, sorry, you guys, this question was, there shouldn't be a prime sign there, obviously. If it gave me the derivative, I'd be done already. Okay, so y prime equals, first is 1 plus x minus 2x fourth times the derivative of the second would be what? 24x to the 7 plus 10x plus the second times the derivative of the first would be 1 minus 8x to the 3. I think these are much less work than actually multiplying everything out. Okay, so that's how I would get this rule out of you instead of giving a question like a binomial. Yeah, either way that could be a toss-up, which is easier. But these, when now I have to find a slope when x equals -1. Okay, so let's do this one again. We'll call this first and this second. We should be able to get quicker at these. So y prime equals the first minus 4x plus 1 times the derivative of the second would be negative 3 minus 14x plus the second 8 minus 3x minus 7x squared 6x squared minus 4. Okay, now it wants a slope at negative 1. So then you're just going to put in 2 times negative 1 cubed minus 4 times negative 1 plus 1 all times negative 3 times negative 14 times negative 1 minus 14 times negative 1 plus 8 minus 3 times negative 1 minus 7 times negative 1 squared times 6 times negative 1 squared minus 4. Okay, so I don't have all the math for this, so let's just see if we can get it right. So this would be negative 2 plus 4 plus 1, right? Correct me if I'm wrong here. That's negative 3 plus 14 there. On the other side, 8 plus 3 should be minus 7. And this would be 6 minus 4. So y prime would equal 2 plus 1, that should be 3 times 11 plus 11 minus 7 is 4 times 2. So y prime equals 33 plus 8. So y prime should equal 41. Did I do that right? Okay, because I do not have the notes on that. Okay, appreciate your trust. Okay, so assuming f is differentiable, find an expression for the derivative. So this one you would have to know the product rule. So this is the first, this is the second. It's a function. We don't know what function it is, but y prime would equal the first times the derivative of the second would be f prime at x plus the second times the derivative of the first would be 3x squared. And you usually wouldn't leave it that way. You'd keep the fx's in the second part, so our last 3x squared fx. Okay, no big deal to change it around, but number 5 is definitely an example that you'd have to use the product rule to be able to get. Okay, so f prime or fg, find the derivative. F of 4 is 2, f prime is 3, g of 4 is negative 2, and g prime of 4 is 6. Okay, so if we're doing f, g of x, okay, this is the same thing as saying the f of x times the g of x, find the derivative of it. So we always know that is the first times the derivative of the second plus the second times the derivative of the first. Okay, so if it wants f g of 4, that's the same thing as f of 4 times g derivative of g of 4 plus g of 4 times the derivative of f of 4. Okay, what is f of 4? 2. G, the derivative of g of 4, 6 plus g of 4, 3, oh, negative 2, I should say. Negative 2, and f prime of 4 is 3. So you get 12 plus negative 6 equals 6. Yep, so it's not a tough question if you know your product rule.